All right, so in the prior section, I guess, to the product and quotient rule, you were expected to have learned these two derivatives, that the derivative of sine is equal to cosine, the derivative of cosine is equal to negative sine. From this, you can actually then, and with your knowledge now of the quotient rule, you can find the derivative of other trig functions. For example, y is equal to tangent x. Okay, y is equal to tangent x. And the reason you can do this, you can split tangent x up into sine x over cosine x, since that is what tangent is equal to. And then you can just go ahead and apply the quotient rule to that. So applying the quotient rule, it's the bottom times the derivative of the top. So it would be cosine x times the derivative of sine is cosine, minus the top, sine of x, times the derivative of the bottom, which is negative sine x, the derivative of cosine is negative sine, all over the bottom squared. Okay? And let me just go ahead and simplify here because, while this is the derivative of tangent, it looks a little bit ugly, and this isn't typically how we see this. So cosine times cosine I can rewrite as cosine squared. And I have a minus, so those will multiply together to be a positive, so it'll be plus sine squared x over, and then on the bottom we have cosine squared. Now, at this point, looks a little better, but still it's not typically how we usually write the derivative of tangent, even though that technically is the derivative of tangent. Now, back in the day, there's a common trig identity used that you probably saw somewhere, whether you remember it or not, who knows. But it's the trig identity sine squared x plus cosine squared x is equal to 1. And so what we can do is recognize that, right here, that's cosine squared plus sine, which is just backwards, but that's this top portion right here is equal to 1. So I can just rewrite that as 1 over cosine squared x. Okay? And 1 over cosine is the same thing as secant, so I can rewrite 1 over cosine squared as secant squared. So I will end up getting then that y prime is equal to secant squared. So again, up here, technically this was the derivative, but I just kind of rewrote it, manipulated it to get it a little bit simpler, and therefore I got that the derivative of tangent is equal to secant squared. So, just use the quotient rule for that and got that derivative. So let me just go ahead and, you can kind of go through in a similar fashion and figure out the derivative for cotangent. It's very, very similar to that. But anyways, this derivative of tangent is secant squared. And if you went through the cotangent, and you might want to check yourself and do this, the derivative would be equal to negative cosecant squared. And it'd be very, very similar to the derivative of tangent. Okay? There's a couple more that we can do here as well, and I'm just going to go ahead and write them up here. If you want to work them out on your own, you can. They are use the same idea of the quotient rule, but it's works out a little different in terms of simplifying it. But ends up being the derivative of secant is just secant x times tangent x. Okay, and the derivative of cosecant is negative cosecant x cotangent x.